Play.
Hey y'all, today we're going to talk about scientific notation and word problems. So before we begin, I want to go ahead and write down two key phrases at the top, and I want you to write these down so that when you come across these phrases or questions in word problems, you know exactly what that word problem is wanting you to do and what it's asking about. So the first thing that I would like for you to write down at the top of your paper is how many more? How many more? That's the first one. And then the second one is how many times as much? How many times as much? Whoops. Oops. Okay, or sometimes it's just how many times. So let's look at both of those phrases. So how many more? Anytime you are reading in word problems and it's talking about how many more, they are wondering numerically addition with subtraction. So how many more? You're always going to subtract. Okay? And then whenever you hear or read the phrase how many times as much, that's talking about multiplication, so you are going to have to divide to know the answer. So let's go ahead and dive on into this lesson. Scientific notation makes large numbers easy to write. It also provides you with quick information about the sizes of the numbers. For example, Pluto are both dwarf planets. Pluto has a mass of this in kilograms, okay? And then we also have a mass of this in kilograms. So what we're gonna be doing is we are comparing. Without rewriting the mass, they want us to tell which of these planets is larger. So we've talked about this already. When comparing exponents, you always look for the larger exponent. So let's write that little note and remind ourselves. When comparing scientific notation, always look at the exponents first. Once you look at the exponents, you can then determine if you need to go back and look at the initial number. So, without rewriting the mass of each of these planets, which of the dwarf planets is larger? So, would 4.006 times 10 to the 21, or would 1.305 times 10 to the 22? Which one of those would be larger? Something to the 21st power or something to the 22nd power? Something to the 22nd power. So, Pluto is larger because it has an exponent of 22. 22 is larger than 21. All right, so how many times larger is the bigger planet than the smaller planet? So there's that phrase, how many times larger is the bigger planet than the smaller planet? So what you would need to do is you would need to look, which one is bigger? Pluto, because it has a 22 as an exponent versus a 21 as an exponent. So you're gonna actually have to set this up. How many times? That means to divide. We wrote that at the top. So I'm gonna write out the first planet, divide that by the smaller planet. And then in your calculator, if you're in scientific mode, you can just type this problem in exactly as it appears and you'll know your answer. Use that EE. Divide So there's your answer. 3.25 761358 times 10 to the 0 power. So it is that many times larger. So if it's to the 0 power, that means a 1. So this is about 3 times larger, because 3.25 blah 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 times 10 to the 0 means times 10 to the 1. So this number times 1. So about 3 times as large. All right, so Pluto is about that much larger than the other planet. All right, let's look at the next one. John is analyzing the mass of planets. The mass of Earth is this number. The mass of Jupiter is this number. Estimate, so they're wanting this, an estimate, kind of what we did right here, about. So that was an estimate. Okay, estimate how many times larger, oh, there's that key again, how many times, so what are they wanting us to do? How many times, they want us to divide, is Jupiter than Earth? So we're gonna go and we're gonna look, Jupiter is bigger, you always look for the bigger exponent. Jupiter's bigger, Earth is smaller, so we're gonna set it up that way. Divided by, because it's how many times. You're going to enter it in your calculator to find the exact answer, but then we are going to actually find the estimate. So 2.8876, use my E, to the 28th, divided by 6.86246. Use your E to the 25th. So this equals 4.207820519 times 10 to the 2. But it wants an estimate. It does not want the scientific answer. My question asked for an estimate. So an estimate, this is going to be about 400 times larger. And this is how I know that. It's times 10 to the 2. If this is 4 point times 10 to the 2, I'm going to move my decimal 2 places to the right, so that would be about 420. So my estimate is about 420 times larger. Okay, so to take away from this lesson, anytime you're reading scientific word problems and you hear or read how many more, you're going to be subtracting. How many times, you're going to be dividing. Also, when you're comparing, look for the larger exponents. When you're inputting your information, always pull the larger exponent first, then subtract the smaller, or then divide the smaller exponent. You may want to go back and watch this a couple of times and review and repeat this video so that you can understand this concept. I hope this helps. Y'all have a great day. Bye.